Good morning. Good morning, everybody. Thank you for being here with us this morning. My name is Dr. Jason Cryan. I am the Sarah B. George Executive Director of this amazing museum. We're really happy to have you here with us. Welcome here. We're here to celebrate, of course, a significant scientific discovery that this museum played a key role in, and we're happy that you've joined us. Like science museums worldwide, our museum here is deeply engaged in the quest to document and interpret life on Earth, both past and present, extant and extinct. Biodiversity researchers here at our museum, like those in other museums around the globe, discover and name new species with regularity that are new to science, including things like plants and fungi, animals and plants, reptiles, all kinds of things. As you may have imagined, or as you may have guessed already from our beautiful surroundings here this morning, we're here to spotlight discovery of ancient life. And that's kind of an exciting thing, especially given that it highlights this museum's role as a scientific hub. The research that we'll be discussing this morning is a significant scientific collaboration that included representatives or researchers from no less than 12 institutions in 5 countries around the world. That's pretty amazing. Now, the Natural History Museum of Utah is the state of Utah's Natural History Museum, so we have a statewide footprint, but we're also proud a part of the University of Utah. Our researchers, many of which here, are also jointly appointed as faculty members in academic departments across campus. And so before I introduce the scientists at the heart of today's spotlight, I'd like to introduce the University of Utah's Senior Vice President for Academic Affairs, our Provost, Dr. Mitzi Montoya.
Thank you. Thank you. And it's an honor to be here. I'm very excited to celebrate this discovery. Discoveries like this are what research universities are all about, and we could not have a better partner than this museum. The Natural History Museum of Utah is an absolute asset to not only the state of Utah, but most especially to the University of Utah. Our vision for the U is to improve the lives of all Utahns and others around the world and around the country. We are very proud of this museum. We see this museum as a portal to amplifying research and education about our world and its past for all ages. NMHU's national and international reputation has grown by leaps and bounds, especially under the leadership of Dr. Jason Cryan, the museum's executive director. He serves as an officer of the board of directors for 3 prominent national museum associations. We are grateful to have his leadership, and we are honored that this museum is able to regularly host teams from other museums visiting our museum as a model for how they can advance their own institutions. The Museum of Natural History is integral to the U's research and academic enterprise. 8 of the museum scientists are jointly appointed faculty. They represent 6 academic departments in 4 colleges across campus. The museum enhances research funding at the U as well. Scientists at the museum, as we'll hear about today, publish their research in scientific journals and present their findings around the world. This museum has a robust educational programming effort as well, including formal teaching on campus and informal education across the entire state, educating young people, inspiring, hopefully, future scientists. The museum is not only the arts and cultural affiliate organization at the U, it's one of many that report to my office and the president's office. I also want to note that this discovery is, in addition to being amazing research in its own right, it's an excellent example of the opportunity that undergraduate students and other students have for research here at the U. I want to say congratulations to the scientists around the world and here at the U that worked on this project. And I especially want to recognize Dr. Mark Lowen, professor in the Department of Geology and Geophysics, for this valuable opportunity that he's providing to the state of Utah, to this museum, and to our students to engage in undergraduate research. Our student, Savannah Carpenter, is among the study's co-authors. What a tremendous opportunity to be involved in such a learning opportunity and to be a part of changing history. This collaboration between the U and the museum opens opportunities for students to participate in biodiversity research, among other areas of research, and is a phenomenal opportunity to demonstrate the impact of the university to this community and to the world. I look forward to future discoveries, decades and eons of future research excellence. So thank you.
Okay, thank you, Dr. Montoya. I am thrilled now to move on to the exciting part of this morning's program. I'm proud to introduce Dr. Mark Lowen. Dr. Lowen is a vertebrate paleontologist. He's an NHMU research associate, and he's a professor in the University of Utah's Geology and Geophysics department. His research is on the biodiversity and evolution of some really tremendously cool dinosaurs. Things like meat-eating dinosaurs, armored dinosaurs, horned dinosaurs. Think things like Allosaurus, Tyrannosaurus, Ankylosaurus, and Triceratops, some of the really iconic dinosaurs. Dr. Lowen and his colleagues already have many dinosaur discoveries to their names, including such notables as the megapredator Lythranax, the horned dinosaurs Cosmoceratops and Utaceratops. And now, this morning, he's going to tell us about the most amazing new dinosaur discovery. And as he comes to the podium, we're going to unveil these amazing dinosaurs that he'll be talking about. So, Mitzi, could you join me? And Dr. Lowen, come on up. Good.
Well, thank you for your kind words. We are very excited today to announce a completely new dinosaur, Lokiceratops rangiformis. This dinosaur, which you can see behind me, is an amazing dinosaur. What makes it amazing are the pattern of horns on the head shield behind the head. Also interesting is the fact that it does not have a nose horn. So this dinosaur is named Lokiceratops, meaning Loki's horned face, and rangiformis, because if you notice at the back of the frill, there are different lengths of horns on this animal. So to us, that's very reminiscent of a caribou. So the genus of caribou is rangifer, so we went with rangiformis, meaning Loki's horned face that looks like a caribou. At the same time, the giant blade-like horns on the back of the frill are evocative of the blades that the Norse god Loki carries. So we really went into the direction of naming it after a Norse god, especially for the fact that this permanently has a home in a Norse country, which is Denmark, which we'll hear from them in just a little bit. So the story of this find is very interesting. I'll take you to northern Montana, to the Badlands of the Judith River Formation. What's interesting is if we go back even further into time, think about dinosaurs evolving on the supercontinent of Pangaea. As Pangaea breaks apart into the continents that we see today, the oceans start to cover the continents because the plates are moving apart so fast that the ocean, middle ridges of the ocean can't sink fast enough. This water is pushed up onto the land. This happened to North America, dividing North America into a western portion that we call Laramidia and an eastern portion. This dinosaur was found in the coal swamps on the shores of the western edge of Laramidia. I'd like to introduce my co-author, Joe Sertich, who co-led the study, who tell you a little bit more about this animal.
Thank you, Mark. My name is Joe Sertich. I am a paleontologist with the Smithsonian Tropical Research Institute in Panama. I'm also affiliated with Colorado State University and the Natural History Museum of Utah. And I'm absolutely thrilled and honored to be a part of this research. It's a huge team of us, worked for many years to pull this animal together. And the biggest question I get about horned dinosaurs as we unveil all of these amazing new creatures is, what were these horns for? What were the bizarre features of animals like Lokiceratops? And I like to think of these dinosaurs as essentially the peacocks of the Cretaceous. They were using these gigantic horns as display features on a big frill shield billboard. And so Lokiceratops, with one of the most ornate frills of any horned dinosaur known really exemplifies this peacock display. They weren't using them for defense. They weren't using them for combat. All these horns are set on a very thin piece of bone, about the thickness of a piece of toast. And so they're using them as big billboards to display to either their rivals, to attract mates, or potentially to help identify members of their own species. One of the cool things that came out of this research was finding that Lokiceratops is a member of a very diverse group that all lived together in the same rock unit 78 million years ago. And so when we look at the other members of this fauna, they all have a similar flavor. If you look, many of them have that double blade on the back of their head. And we consider that to be kind of the fashion of the time. And each of these horned dinosaurs had its own style. So Lokiceratops' style was this gigantic pair of horns with the asymmetric spike in the middle. And all of this was pieced together from a huge exploded skull, almost like dropping a huge vase on the ground and having to piece it all back together. And that took all the members of the team many, many months to get this puzzle back together. And as part of that research, we also had to decide evaluate where this dinosaur went in the family tree. And to do that, we worked with some of our experts on dinosaur phylogenies, one of those being Savannah Carpenter, a recent graduate here at the University of Utah, and an expert in the phylogenies of horned dinosaurs. I'd like to introduce her next.
Hello. Being able to work on this dinosaur has been an amazing opportunity. A very important part of understanding Lokiceratops was understanding how it actually fits into the ceratopsian family tree. We compared the morphological traits of hundreds of ceratopsian bones all around the world to conduct a phylogenetic analysis and have concluded that Lokiceratops actually falls into a clade that consists of itself, Medusa ceratops, and Alberta ceratops. In addition to the remarkable scientific insights gained from studying Lokiceratops, we've also been able to use the scientific framework of this paper in the creation of an online phenomenon-based middle school teaching module titled Research Quest Triceratops Traits. This free online investigation was created here at the Natural History Museum of Utah for middle school teachers and students. It was largely based on the phylogenetic research completed in this study. In the Triceratops traits investigation, students explore the evolutionary pathway of horned dinosaurs by interacting with real fossil data and analyzing shared traits, deep time maps, and phylogenetic trees created by our team. Since its release in April of 2022, the Triceratops traits investigation has been a huge success. It's been utilized by an average of 300 teachers per year, and it's estimated to have reached over 73,000 students both in Utah and beyond. Next, I would like to introduce a fellow co-author of this study, Brock Sisson of Fossil Logic, who was instrumental in the preparation of this dinosaur, Lokiceratops.
Thank you, Savannah, and good morning. It was my job to prepare the specimen of Lokiceratops and restore it. The skull was actually reconstructed using cast replicas of the original bones, and the missing elements were created using mirrors of the bones from the opposite side of the animal. During the process of assembling the skull, Joe, Mark, and I realized that not only did we have a very large and very impressive skull, but it was actually different than any other centrosaur that we knew of, which was pretty amazing. The completed reconstruction that you can see behind me was then used as a base to set in the original bones and in a clutch mount system so that each of the individual bones could be removed and made available for future studies. The replica skull of Lokiceratops will be here at the museum for the future, and then the original is at a museum of evolution in Denmark. We also created this life restoration over my shoulder. This was done by, again, using a cast replica of the skull and we removed the distortion that occurred in the original bones over millions of years. And then we covered those with the musculature and soft tissue, which was in turn covered by skin and keratin for the horns and beak. During this whole process, we tried very hard to use all of the knowledge that was available to us to make it as accurate as possible. In fact, the skin pattern that you see on the finished sculpture is based on a specimen here at the Natural History Museum of Utah called Nazutoceratops. The final sculpture that we see is just one interpretation of how Lokiceratops would have appeared in life or could have appeared in life. And I'll turn the time back over to Mark.
Thanks, Brock. So for us, this has been an exciting journey. Being able to actually discover, standing around a table, looking at bones, clicking them back together, and for the first time having that eureka moment of, wow, this is a new dinosaur. We're the first person to see this in 78 million years. That's pretty amazing. And really what this study is telling us that we have completely underestimated the diversity of ceratopsian dinosaurs throughout North America. So many, many more finds are coming your way. We're working on at least 5 new dinosaurs within this family that we haven't finished the research on. But at the same time, I would like to take you to the Museum of Evolution in Maribo, Denmark, for an unveiling of the actual skeleton and skull of Lokiceratops. And I'd like to introduce the director of the museum, Christoph Knut, and he's going to tell us a little bit about the specimen over there.
Thank you very much, Mark. Can you hear me?
Yes.
So the connection is good. Welcome to Denmark, and welcome to the Museum of Evolution here in Knuthenborg Safari Park and on Lolland. Behind me, we have the original Lokiceratops skull, something that we are extremely proud of having here and being able to show to the public. You can't see it, but outside it is actually sunshine, and you are in the middle of a safari park. We have elephants and rhinos and tigers and lions. And one of our jobs is to talk about conservation and how we can take care of these animals in the future. But it is also very important for us to talk about the animals that are extinct. And obviously the Mesozoic era, the age of dinosaurs, is very important in that context. And therefore, being able to introduce a completely new dinosaur is very big for us. It is here in the museum with a lot of other dinosaurs, but it is really, really, really something extremely important for us. We are an old institution. We've been open to the public for 150 years, and we sort of intend to be open to the public for another 150 years, and supporting as much as we can science, and in particular conservation is very important for us. Finally, I'll just say that it has been a huge honor and privilege to work with Mark and Joe and your team. You are honestly very inspiring people, truly professional academics, and it's really been very big for us to meet you guys and to work with you. And finally, Brock, Seth, I don't know if he's around, but you guys, the work that you've done with reconstruction, the Lokiceratops, but also preparing the original bone behind the skull behind me, your attention to detail and your work ethics is really amazing. That's all from Denmark so far, and back to you.
Thank you so much. So at this point, we'd like to open it up to questions. If anybody has questions for the team, we'll try to answer those for you.
Hi, I'm Alexandria. I'm from KSL News Radio. You mentioned that you underestimated the diversity of these animals. I was wondering if you could elaborate on that.
So the amazing thing is when I started as a paleontologist, we were taught that there can only be 2 ceratopsians at any given time, one from this side of the wall and one from this side of the wall. As we started digging, we found that that's absolutely not true. And the amazing thing is in this small area, smaller than Salt Lake City, at the same time in Montana, we have 5 elephant-sized animals living at the same time. That's unheard of. That's like going to the Serengeti and seeing 5 species of elephants. You're not going to do that. So in order to have that many animals living together at the same time, you're going to have some sort of explanation for how they would not outcompete each other. And that's when we went to the world of birds and we looked at the ornaments on these skulls. And we started to recognize like cichlid fish or like paradise birds. These animals are separating themselves into different species based on mating behaviors and preferences, likely. So we think, and we actually know, we're going to be reporting more and more animals from this group of dinosaurs. We think we probably know less than 1% of the animals that belong to this group that lived here in North America. And going forward, we're just going to try to increase that more and more so we have a better knowledge base. Other questions? Yeah.
Maybe I should keep. I'm kidding. How long was the process from when you first started working on this to now where it can be displayed in a museum or a replica can be made?
Yeah. You want to take that, Brock?
Oh, sure.
So the original discovery of Lokiceratops was made in 2019, I believe. And it took approximately a year to get it out of the ground, get it prepared, and then get it ready for display, making the molds and reconstructing the skull like I talked about earlier. And then the process of researching it took an equal amount of time. So we're about 4.5 years into this process. And, that's actually fairly quick for a new species, I think.
Yeah.
So
You can stay up here. I'll just add to that. We had 10 co-authors and the amount of time it takes to review a paper increases exponentially with the number of co-authors. So that slowed us down a little bit. We did first submit this paper a year ago, February. So it has to be looked at by peer reviewers and our colleagues around the world to make sure that what we're saying is correct. And they really did help us improve the paper. We're very proud of the paper. It's a difficult read for most people, but if you are into the anatomy of ceratopsians, we geek out over that stuff. It's really amazing. Other questions?
Do we have any questions from the online audience?
This is terrific, by the way. Are there going to be any of these discoveries in the state of Utah?
I'll let Joe take that one.
Yeah, so this is obviously from outside the state. This is from Montana, but Mark and I are currently working on 5 other horned dinosaurs that are from Grand Staircase Escalante National Monument. So several new horned dinosaurs are coming out of the ground. They're being prepared. Some of them are in the process of getting reconstructed, like the cast behind us. And we hope to have some of these new horned dinosaurs from our own backyard here in Utah unveiled within the next year or so.
Other questions? Sure.
Because they are here in Utah, what does that say about Utah's prehistoric environment, I guess? Like, what does that mean for Utah?
Yeah, that's a great question. So this is the first example of a fauna, a single group of dinosaurs that hits that number of five horned dinosaurs living together. But we have evidence that there are places here in Utah where we hit that exact same number, 5 very different horned dinosaurs living together in what would have been a tropical or subtropical environment. And so each one of these fossils is a big piece of a puzzle that helps us understand how evolution and how climate change are interacting. And it really informs us a lot about the world around us today as we see climates change and habitats change.
So many animals today have asymmetry from one side of their ornaments to the other. Think about things like caribou. If you've ever seen deer, deer antlers are not carbon copies from one side to the other or mirror images. So that's a natural thing. The interesting thing for us is we have to determine, wow, so if you found one side of this animal in one place and the other side of the animal in another place, would you call those two different species? Would they be the same species? So we actually look at bone beds of multiple individuals of different ages to actually determine what is going on with variation. My entire career, I have studied variation in dinosaurs. I was fortunate enough to work on the museum's world-class collection of allosaurs. So looking at Allosaurus, I had to understand what were the differences as animals grew up? What were the differences between different species? And looking at many thousands of specimens, I think I have an idea of what variation is in Allosaurus. At the same time, our team has been looking at thousands and thousands of specimens of ceratopsians, many of which are housed in this museum. And we're actually using that data to understand variation within these animals. Fortunately, the animal that's closest to Lokiceratops, Medusaceratops, is known from a bone bed of multiple different sizes of individuals with enough frills for us to say conclusively that this animal is a different species. Great question. Any online questions? Anybody else? Carrie, did you have a question? Okay, well, thanks so much for coming out. It's been a pleasure to share this dinosaur with you today. Again, you can come to the Natural History Museum of Utah and check this dinosaur out and its life reconstruction in the next, for the next year.